Does anyone have questions for Jeremiah? Jeremy does. Okay, go for it, Jeremy. And you guys can unmute yourselves now. I changed that setting again.
Hey, Jeremiah, thanks. And once again, awesome presentation, man. This is looks like you put a lot of work into in putting this together. I just wanted to know a little bit about what you're working on next, and where do you see like where do you think like the best, like we've taken a look at so much different stuff. What do you think you have the most hope for right now as far as an experiment, and for like we're just banging out cost effective stuff right now? Is that the deal, or is
No, actually, right now I'm revisiting some old ideas that I've always misunderstood. It's easy to read through Brown and completely misunderstand what he's claiming. Plus, he's not really that clear with it. In fact, a lot of these technologies operate by mechanisms which are not obvious at first. So as I learn more, and especially thanks to APEC and all the people that have just poured out information that's kind of groundbreaking, I've had to revisit a lot of the old concepts that I previously gave up on. So it's not so much that I'm going back to simple or cheap. I'm going back to things which I think have been around for a long time because they're the most easy to replicate because anybody can do them. And my main goal is to test out technologies which I think anybody can test. Because quite frankly, it doesn't matter if you have a really groundbreaking technology which requires super exotic components or really expensive parts or unobtainium. If it can't get into the market in a mainstream way, if people can't build it themselves, if they can't test it, it's never going to get out there for all of us. So we need things that are actually usable.
I also point out that like a lot of things that would have been super materials back in the 50s when Brown started working on all this stuff are readily available now for really cheap prices. We have way better dielectrics, we have way better semiconductors, way better. There's a lot of material science that has evolved in the years in the 70 years since Biefeld Brown was first doing a lot of these experiments. So we have that advantage to this as well. Could you comment on any of that with regards to other people out there, meaning trying to start their own labs up? I mean, we've thrown some ideas around about I know a lot of people have thrown this idea about like a ranch, like a collaborative effort where we can all get together on like a big, project. And then like we've talked, then we've had other members of the group say, oh, we don't need so many cooks in the kitchen, too many cooks in the kitchen spoil the soup. So it's like maybe a big operation isn't a good idea. It's better to have these small like groups that are like kind of working on it. And I don't know. I kind of bring a lot of these people together, and I'm sure after the conference, a lot of people are going to hook up with one another and have their own, go off in their own directions, hopefully, and add more to, other people abandon teams that they were on and join other teams as this crisscross and stuff. I think there's a lot of stuff going on right now. Could you comment on any of that you know about, or?
I wish I could comment on more of what I know is going on right now. Unfortunately, the reason why I only mentioned Hector and Richard in my slides, and why I just briefly mentioned Nasicas, is because there's not really a lot of people doing this specific type of research. Now I should probably throw in, just for the record, that the technologies I mentioned today are just a fraction of what we're working on. We have Ziggy's drive. That's going to be a huge thing that requires a lot more construction yet. I've been pretty booked up for time. We have a lot of different technologies that we are dabbling around with right now that I'm not going to get into just because I don't have enough data to really say one way or the other what I think about whether they work. But just keep in mind, there's good things coming around the pike. And if this one doesn't work out, there's a lot more where that came from.
Also, what Jeremy was talking about earlier with the new and the cheaper, the better technologies that are available with power supplies and components. Some of these experiments actually require the older stuff, like the vacuum tubes that you can only buy new old stock. So it's not all that technology got better and this stuff is more readily available. In some cases, it's harder to find those old components that are no longer manufactured.
Yeah, that's another really good point too. Is especially Richard Bandura points out again the point of isolation, where tubes are probably one of the best ways to actually do that, because almost no solid state semiconductor diodes offer the same or even close to the degree of isolation that good old-fashioned electron tubes do. And Jeremy, to your point, to answer your question about collaboration, there's never been a better time for people to collaborate. If you're not collaborating in person, if you don't have a lab to work on, but you have great ideas, at least find somebody online, find somebody on Zoom, on Skype, on Google Voice, find somebody that you can talk to that is working on this stuff, and get together and start to share your ideas, because it is the prime time to do it now, and you're not always going to have that chance.
No, it's super interesting about that is the tubes thing. Those things went out when the transistor sort of took over in the 50s with microelectronics and semiconductors. The tube industry kind of fell out. So the only ones that kind of picked it up or kept it going were actually, guitar amplifier manufacturers, because you can't get that classic tube sound without the tubes. And so if we're going to reach out for anyone who's improved, because think if the tube industry had the funding to develop over all these years, what kind of tube technology we'd have by now, as far as the materials for constructing tubes. But I assume that some of these guys have some stuff figured out with the guitar industry. I wonder if it's similar for the.
Let me guys, let me jump in real quick and go to Thomas, because he's had his hand up for a bit. Sir?
I just wanted to say I have a electrical engineer friend here in New Jersey who works on guitar amp tubes. I'm going to bring him down to the lab next time Jeremiah's down.
Okay. Okay.
So,
Thanks, Mark. Let me get Thomas in. Thomas, go ahead, sir.
Yeah, I was just going to say, I actually have I guess a couple points now, because the conversation continued on and it created more, more content, I guess, to kind of vomit out here in to the ether, so you guys can basically consider it. When you mentioned the glass tube, the tube technology being phased out with the transistor technology, it pushed it out of the public view. But it's still there, because transistors can only be made in vacuum tubes. The vacuum chambers that they use for that. So that might be something you need to think about when you're trying to communicate with someone about information about how to basically work with them, would be to approach somebody who works in the industry for manufacturing transistors in maintaining those tube arrays, in order for them to basically grow like their films and whatnot in the vacuum chambers, or with a chamber that they're controlling a set amount of plasma for plasma deposition and whatnot. The other thing I was going to say is somebody to maybe look up on YouTube would be Glass Slinger, because he does a lot of vacuum tube rebuilding. So for information, so that if you want to work with glass tube technology, rather than trying to hunt down new old stock, just build some new stock. I mean, glass is fairly easy to come by.
So Glass Slinger.
Yeah.
I'll go check it out. Where can people find him and more information on him on YouTube?
That's his YouTube channel name. So.
All right, yeah, YouTube Glass Slinger. I'll type it in the live chat. That's good call.
Right. Yeah. I mean, he's the first person I heard mention how when he was trying to lower the vacuum inside his tubes, and he was having issues with getting low enough, going through a whole discovery process where he finally kind of stumbled upon the Getter technology, which is, just something to absorb the rest of the atmosphere out of the environment when you heat it up, to create a chemical reaction, and that would drop the vacuum down, because if you're using iron,
yes,
and you're trying to get rid of oxygen, you react it with the iron, and the iron oxide can't evaporate into the chamber anymore, so it's now a solid. It gets
they'll do it in pure nitrogen, and then they'll put a component which is a nitrogen harvester to suck up the rest of that light nitrogen that's in there.
Right. So, I mean, I looked at using something similar without realizing that it was a Getter technology for clearing out the oxygen trapped inside of an argon tank while you're
that's brilliant
doing work with just candles, turn it into carbon dioxide, because at least that's less reactive, plus it weighs it down, so it'd be easier to extract out of your chamber and repurify your argon. Just keep reusing it. It was just a simple concept. 2 chambers, you're using a welding mechanism for laying down traces of metal, and then to get in and out to get the stuff, you want to pull all the argon to another tank, extract, close the tank back up, then cycle everything that's in that chamber back out, and the argon back into the chamber and start the process up again. So I was going to say about the lab system. Has anybody considered the idea of breaking between the two of the giant collaboration and the too many cooks in the ruining the soup, where you basically have multiple facilities and have a free like exchange of people being able to move between facilities at different locations? So it's something that I had thought about doing a long time ago. That's kind of a little bit of what this whole thing is here, is that it's the idea of building up the atmosphere of the environment that you're working in, so it feels more like you're in a more futuristic environment to keep people's energy level high, so that way while they're working, they're not even if they're having mistakes or something like that, or failures and whatnot, it's not going to lower their mental level, so that they'll basically want to stay in bed the next day instead of getting up and actually trying to work on something again, as well as kind of foster that kind of the concept of being on a starship. You have to work with other people. That means you're most likely going to have bunkmates and people that you can't get away from. If you can foster that idea of a more of a camaraderie like that, like you see imagine in things like Star Trek and whatnot, not only will you be able to basically work longer periods of time and get more productivity out of it, but you're talking about the financing at one point too. People are going to want to basically tune in and see something where it's exciting looking.
Well, the thing is, right now with COVID and everything, where everyone's locked down, we have all these independent labs. So I think I like this idea of just being this beacon for all these independent labs to get together and work on this stuff.
Right.
And then we're trying to get the attention of guys like Electric Boom to jump on board and be like, hey, let me start getting involved with this, or let me give you guys equipment, or start talking about what you guys are doing. That's kind of the direction I'd like to see it go. Rather than build one single Titanic ship, we need to build like a whole armada, or it should be like a series of ships, like
Right.
where it's an unsinkable fleet, rather than put it all in the Titanic. And what happened to the Titanic, right?
Well, the other thing too is he mentioned the humidity in that one experiment. If you have multiples of these places across the U.S., you're going to have different environments to try things out simultaneously. Like you could be doing something close to the Great Lakes where it's cooler and maybe a little higher humidity. Somebody else is out in the middle of the boot heel of New Mexico, where it's super bone dry and the temperature can be really high, or it can be really low depending on what time of day, because at night the temperature drops down to freezing, whereas during the day it could be over 100 degrees and you wouldn't break a sweat because there's no humidity in the air.
Well, Thomas, let me jump in real quick. Franklin, you had a question. So Franklin, let me get you really quick, and then we'll kind of come back to this.
So my question is, I noticed, Jeremiah, that you dismissed, say, the lifter technology very quickly in the beginning of your presentation. Now I haven't actually done anything with those lifter tech, but I've seen like the videos, and you see these things just leap off the table. And I'm familiar with things like ionization generators, and they produce a breeze.
Well, I can answer that question, Franklin, right off the bat. I've spent a good number of years working on advanced lifter tech, up to the point of producing ones that are just damn near close enough to lift their own power supply. As far as lifters go, my best thrust to weight ratio is about 4-to-1. So when one of my thrusters kicks up, it will tear off its own threads and then continue to tear off its own wires with its upward momentum on a single ascent. So in terms of ion propulsion and the amount of thrust that you can get, it is huge. In fact, it's over 40 times more efficient watts per gram of force, theoretically, than the best propellers or jet engines. It's just that to try to get those efficiencies out of ion thrust, you need an incredibly high ion saturation, a control magnetic field, in order to keep the ions constrained, and then you need multiple correction electrodes to keep the electric fields from having a reverse electric field component that would cancel out their forward momentum. But long story short, ion thrusters are certainly not lacking the thrust. So when you see them pick up off the table, it's not because it can't be ion power. It definitely can be. And then secondly, to answer your question in the beginning, I didn't dismiss ion thrusters. There is a small electrogravitational, theoretically a small electrogravitational thrust from ion thrusters, but it's actually in the opposite direction of the net upwards thrust. That's the reaction force against the surrounding medium. And so the amount of gravitic thrust from those systems is so small that you'd never be able to see it under normal conditions or even under atmospheric conditions, because you couldn't get the potential between the electrodes high enough to get that number big due to ionic leakage. So it's not that they don't generate anything other than ionic thrust. It's just that 99.9% or more of their actual thrust is in fact reaction mass.
Now, the fascinating thing I saw was your plastic panel that can attract everything. I thought that was great. I mean, what kind of how are you achieving that? Because I know that any central spherical charge can attract, anything, but what you had there certainly wasn't spherical. So I'm just kind of curious.
But it actually was. It actually
Was it?
was, and that's the funny. No, you're correct about that. It's a hemispherical charge. So that panel wasn't just a flat panel. It was actually a ribbon cable that was pulled out of the same printer the transformer came from. It's a 1¼ inch wide by 4½ inch long ribbon cable. It has some 30 conductors in it, and every other conductor is attached to the same row. So there are 2 rows, and they just back at 1, 2, 1, 2, 1, 2. That those series of conductors are hooked across the high voltage output of a 7 kV transformer, and then they're ramped at about 250 kilohertz. And so the AC field developed between those 2 lines going across that entire ribbon cable that are parallel develop an electric field between themselves and the surface of any other material, whether it be metal or dielectric. And so the divergent field coming off of those flat electrodes means that anything trapped within that field will want to move towards the place of highest energy concentration, which is of course right up against the panel. It is a near field effect. It only is effective at about maybe 3 or 4 millimeters away from the surface. And the primary reason is the separation distance between the conductors is only about 1 millimeter. So if you were to separate them out to about 4 or 5 millimeters, then you would get about maybe a 10 to 15 millimeter range. And I've tested it as wide as 1 foot, and you get about a 2 to 3 foot range out of it. So it works better as it gets bigger. But you also have to have a consequently higher voltage to pump it, because you need those volts per meter. It's not just about the frequency, it's about how many volts you have in a given small volume of space in order to create that attraction force through the, what do you call that, the displacement current that takes place. Go ahead.
Yeah, you mentioned that it's hard to build these systems to measure thrust because the wires themselves are exerting a lot of force. Personally, right. I think that, gravity is probably that force. So in some ways, it's like you're throwing the baby out with the bathwater. It's like that attraction of the wires to the wall. That is what.
Well, that's called electrostatic field attraction. And Franklin, the way we get rid of that is by getting rid of the wires. And we can do that because luckily in 2021, parts are small and components are amazing. So instead of using large benchtop power supplies with large feed cables to run my experiments, I'm just building little battery-powered supplies and putting them right onto the experiments themselves, getting rid of the wires. And that means if the engine works freestanding of its own accord with no other external connections, then it should work in space. At least that's the idea. And when you have the wires, they contribute error, and you want to eliminate all error if you're trying to do a good experiment. Wires just are another place for error that you should get rid of if possible.
Okay, you know what? Let me go to Eric Hermanson, who is asking about the Can-A drive. Eric?
Yeah, I just wondered. I haven't heard of it. Yeah, I heard a lot about it about 5, 6, 7 years ago, and I looked into it a bit, and then it just disappeared. Does anybody know what happened?
I would certainly like to. What is it? Can you describe what this drive is real quick, Eric?
It was a real interesting looking thruster. It kind of looked like one of those Roomba vacuums. I mean, it was like disc shaped, but then it also, I mean, you can look it up on the internet and find drawings of it. It had like all these notches in it, and it was really futuristic looking. it was some type of RF, I think RF type thruster. They had a theory on their webpage that was derived. It didn't look like a very clean theory. It looked like sort of like a a Taylor series expansion of a force equation. Sort of, it was like a bunch of terms in this really long equation. But I don't know. It got a lot of press for a while, and I don't even know who was behind it. But or actually, Guido Feta, I think, might have been his name.
You know, I have a photo that's up in the message there. There's an article on The Verge that shows a picture of it. It does look like a cousin of the EM drive.
Okay, yeah, there it is. I saved the website because they took it down, but it looks like it's back up again.
Can I
so
add
anybody
something
know
to
anything?
this?
Yeah.
Yeah, I know about it.
Okay.
Because
well, what's going
I
on?
know who tested it. Let's see, Jess Sponable, the same guy that was funding my research, was from DARPA at the time. He was the one that was basically courting them. He also paid Sonny White, which was Eagles Works at the time, to do vacuum testing on it. And in fact, you can find it under Sonny White. And if you put in Canadian Drive and NASA Eagles Work, you will find the basic report that talks about the testing. And in fact, I just forwarded that PDF to someone else who was asking me about my own asymmetric capacitor stuff from DARPA. I have it here somewhere. I got to find it real quick. I think things on my other computer though.
Yeah, thanks.
Okay,
Hector.
but it sounds like there really hasn't been any news in at least 5 years though.
Yeah, the last I checked, that was all that came to it, and they were still looking into it, but it didn't seem like it was moving forward at all. In actuality, the last thing I remember, yeah, it was considered like a knockoff of the EM drive.
Actually, if you hold on a second, whenever I see a site like this, I usually use my website down. Hello?
You can try Wayback Machine and probably get the older version.
Oh yeah, you could do that too. I usually save the website with a script. I have some pictures of the device, but I guess it doesn't really make sense to show them. You could just go to archive.org and see them.
Yeah, and also I want to try and keep things focused on Jeremiah's presentation, because we actually have a surprise mystery guest at some point. I'm not kidding; it's a surprise to me. So hopefully they're dressed.
Okay, well I'm done.
Okay. Well, does anybody else have questions for Jeremiah? Now he's laughing at me. I'm serious. We have a surprise mystery guest.
Oh, I was laughing because I was thinking, Tim, you're no fun.
No idea. I know.
You never know. If it shows up, you can always kill somebody's video, but the rest of us can laugh about it.
Well, somebody has to be the downer, right? Somebody has to be the town downer. That's me.
Yeah. I guess. I thank you for taking on that responsibility. Yes,
that's right. That's right. I'm a ray of darkness in a room of light. So.
I think.
No, we all know it's thanks to you to make this happen, Tim. We can't appreciate you enough. That's the truth.
Well, thank you, sir. Thank you. But
Ron Kita has his hand up.
Ron, do you want to go for it, sir?
Unmute. Am I
Yeah,
there?
there you go.
Okay, for Jeremiah, I mentioned a while ago, Rex Schleicher, Colonel Rex Schleicher has the NEMPS patent, nonlinear electromagnetic pulse patent, and I'm not sure if he ever investigated that, but one of the things that I shared with, when I was friends with him, he's now living in Albuquerque, New Mexico, and we were in, you had it on your slide, it's called the Feynman disk paradox.
Yeah.
Okay, the Feynman disk paradox, I think there was one configuration, instead of steel balls, they used electrets in terms of having a better charge. But also what I wanted to mention is, I was always intrigued by it and used the word theoretical, but you ever hear of Graham and LaHose?
No, I haven't, but I'd like to know more.
Okay, if you type in Graham, Graham, and Lahoz, Lahoz, you should find that they supposedly they did the confirmation. It took me years to find a confirmation of the Feynman disk paradox. And
You actually found it? That's amazing. No way.
well,
Okay, this is great.
It's just a question of time. It should be. Did you find it there or not?
I'm looking. It looks like there's a. It looks like in 1980 there was a experiment that they did. I'm trying to find the actual paper if I can locate it. Experimental decision on the electromagnetic momentum.
David Mathis just wrote Graham Lahoz. I think that may be Lahoz. Graham Lahoz. David just wrote that in.
And also, in my concluding remark is, as far as Kinnate technology, I forgot who asked me. It may have been somebody asked me, Frank Mead or somebody. They said, you know about them? I said, well, they're located in my town, Doylestown, PA. I was to meet with them over the years once he never would meet with me, but if they exist, they now exist in Warminster, PA. That's my comments. So.
Thanks, man. I've got that paper on. That's it's pretty awesome. It's a huge paper, 311 pages. Looks like in total, but of it, just the 16 pages I think relevant. Looks like it's a snip out of a bigger book. Eh?
So let's go to. I think Michael Himes has a question. He's unmuted himself, sir.
Yes, please.
Yes, Tesla had a tube rectifier in his electric car. He harvested the Alfvén ring current. Now I'm revisiting that because I believe people are unaware that when you have a scalar field or a longitudinal wave function, it links with the Earth electric circuit.
I have read a lot. I've read a lot about trying to link with the Earth electric circuit and the interesting tests that are done in Faraday cages that apparently do affect measurements that are taking place of it. So I know that some of the experiments we did worked fine without the Faraday cage, but the second you put them inside, they no longer work, and that's a report that we've read multiple times. But what I'm really interested in, Mike, is I mean, you know all about the chirality of materials or the chirality of materials, and I'm trying to still fully grasp or wrap my head around how to produce these Alfvén ring currents and how to pump the Chiro ring resonator at a frequency that's close enough to something that I can actually get it ringing at, because it's an awfully small set of rings, and I was trying to drive it at a frequency significantly lower than its resonance.
Your resonator, the one that you use for mixing up stuff, the 100 cycle one, anyway, the ultrasound, that's the frequency, resonant frequency of silicon or silica. And that's good enough to stir the Alfvén wave ring currents. It's like an LC tank. You have your resonator and then the mirror image of that resonance in the ground. And it stirs the earth current. It's the way you access. Tesla found that out, and that's how he ran his electric car.
So in that case, when I really get it ringing hard, it's actually pushing against the ground that causes the lift?
It's a field effect. It's an ether effect, as well as ion discharge.
Oh, cool. Because I did not realize the contribution of the ionic component in that circuit.
It's a matter of density. Your phonons are being shed by your transmitter, and it's becoming lighter, and there's more pressure from below. So it's like low pressure above your disc that you're wanting to lift and high pressure below. And what people don't take into account is there's so much current in the Alfvén wave, it's unimaginable. It's the earth capacitor discharging. And it doesn't matter the size of it. The resonant frequency is critical.
That's very interesting. It's going to take me a while to wrap my head around all the concepts to be able to actually build this thing. I've been playing around with different chiral materials. I have been, I've been playing around with one specific mixture, which you're quite familiar with, and I've had pretty good results creating a nice set of film that has graphene and some chiral molecule in it mixed with a decently strong, 99% acetic acid. But I still have yet to play with some of the other newer materials that are out there, and I'm still not sure how to drive the entire array yet. I was thinking of just ordering some PCB printed chiral resonators, but then I was wondering whether or not I'll actually be able to drive them correctly.
If you want to see the separation of electrons, your valence electrons and the other kind, look up the Hirsch vortex tube technology. It goes hot on one side and cold on the other.
Yeah, I built quite a few of those things. They're a lot of fun.
Well, they're not just a lot of fun. It teaches you that the phonons are being discharged. That's where the hot end is.
I've never thought about it like that.
It's the vortex effect.
And how does that apply to electromagnetics in this case?
Well, a vortex is going to create its field.
Because I get the heat. I mean, I understand the heat exchanger phenomena going on in the vortex tube, and it operates very much like a conventional heat exchanger, only you don't actually need a barrier wall between the two counter-flowing air streams. But in terms of electromagnetics and electrodynamics, I guess I'm having trouble linking the analogy.
Well, it's the spintronics of it. That's where your magnetics are.
Yeah. Well, let me jump in really quick. I think that we're just about, let me meet you out, Michael. Thank you again. Jeremiah, I think we're just about done with the Q&A. We do have a mystery guest. Should we switch over to that individual now?
Yeah, I'm all good to go if everyone else is.
Okay.
I can't wait to see this.
Yeah, I'm a little terrified, actually.